Exercise 3H on number patterns on page 146 of your textbook. Number patterns or sequences, same thing, have numbers that are called terms. So there's a few keywords I do want you to note in this. Like I said, this topic is quite straightforward. It's pretty fun. It's all about pattern recognition, so whether you can identify what patterns are being used. So number patterns, or another word that we use is sequence, and they have what we call terms. Now you guys know if I say a school term, how many school terms are there in a year? 4. So terms just means how many or what position it's in. So let's start with a very, very basic pattern. This one might be really tricky for you guys. Do you want to guess what the next number is? Wow, what's the next number? 5, and then? I'm going to stop there. You guys already know. So this is a number pattern or a sequence, and this right here is my first term. That's my second term, third term, and so on. Okay? Now, in this case, the term coincidentally lands in the same number. So for example, the third term is 3, the fourth term is 4. That's a coincidence. It's not always going to be like that. So in this case, how do you know what the next number is? Now you guys already know, obviously, but how do you know what the next number is? Lucas?
Because its pattern that you showed us at the start,
1,
2, 3, it had 1 going up, then going up 2 as it's plus 1.
Good, that's the one I'm looking for. It is plus 1.
And therefore 3 plus 4 must be 4, 4 plus 1 must be
Awesome.
5, 5 plus 1 must be 6.
That's correct. So we're going up by plus 1s. Yes, Taylor, do you have something to add?
If you whenever you keep adding, it's pretty much just a common difference.
Perfect. That's the term we're looking for, coincidentally. Common difference. So what does the word difference mean? Henry? Not the same. So in this case, the difference we're looking for is the numbers that add or subtract to get the next number. So you guys know that the next number, and it takes plus 1 to get to the next number. So a common difference just means that every time we add the same number or subtract the same number. I'm going to give you guys a different pattern now. I'm going to give you a different pattern. Let's say I go with 7, 4, 3, 0, -3, and then what's the next number? How'd you guys do that? What's the common difference? Henry? -3, awesome. So every time we go down, we're minusing 3. And that's what we call a common difference. So I want you guys to write this down. Common difference. Common difference. That's one of the types we're going to be working with today. Difference. Now, common difference just means we're increasing. Can you guys read that up the back? Yep. Increasing or decreasing the same amount. Increasing or decreasing the same amount. That's all that is. Yes? That's a very good point. It should be. Let's fix this up. So from 7 to 4, it's take away 3. From 4, take away 3, it's 1, and then -2, and then -5. Yeah. Thank you for picking that up. That is definitely a mistake on my behalf. So we're taking away 3 on each side. So it's 7, then 4, then 1, -2, -5. So common difference just means we're increasing or decreasing by the same amount. Now, can anyone think of another way that we can make a sequence without adding or subtracting? Yeah. Good, by multiplication. So I want you to copy this down as well. I want you to write common ratio. Common ratio. What does the word ratio mean? Noah? What does the word ratio mean? Or where have you heard it? The amount of something, yeah? It means that we're comparing something to something else. In this case, we're talking about multiplication or division. So, I want you guys to write down, after you've written common ratio, I want you to write multiplied / divided by the same amount. I know it's a lot of writing, but hopefully you should be able to refer back to this. So common difference and common ratio, those are the two most common types of patterns we're going to be working with. So an example of a common ratio, let's say Oscar, give me a number. 3. Lexi, give me another number. 7. All right, what's 3 times 7? 21. Oh, that's times. That's a big number, Lexi. Why'd you pick 7? 21 times by 7. Oh, that's a hard one.
60. Oh, times 7.
21 times 7.
No, 147.
147 is correct. Now, I'm not going to ask you guys to do 147 times by 7, but you get the idea. Every time we go up, we times by 7. And theoretically, if you had your calculator, you could do this forever, couldn't you?
Yes.
It's also a common ratio if we divide. Okay? So let's say the number was not 321, 147. Let's say it was 147, 21, and then 3. Well, we know because we did the other way around. So we know that it's, divided by 7. Now, there is a more difficult, more advanced concept here, but this is not going to be accessible. I just want to ask, what is the same? So I can multiply by something in order to get the same as divided by 7. What do I have to multiply by? Yeah. 1 over 7 is correct. So if I divide by 7, it's the same as if I times by 1 over 7. Same thing. Now, I'm okay with either, but in future, as in future years, it'd be a good idea to keep that in mind. Yeah. Sorry? Yeah, exactly right. So for our common ratios, we don't want to say divided by something. We want to say multiply by something. Okay? So in the first one, as in this pattern right here, it's pretty straightforward because you know it's just times by 7. But we don't want to write divided by 7 because I don't know why, but divided looks weird in a common ratio. So we want to use multiply. Now, we know that divide by 7 is the same as multiply by 1 over 7. So that's the same thing. Just like how, for example, dividing by 2 is the same as multiplying by a half. That makes sense, right? Yeah? Okay, so those are the two there. There are actually a number of different patterns. I'm not going to go through all of them because some of them are very, very, very unique. But I do want you to keep these two in mind. The common ratio and the common difference. Now we're going to do 2 examples. So let's say I have a pattern and it looks like this. 6, 18, 30, 42. What's the pattern? No. Times by 3, sure? Alright, let's try. So 6 times by 3 gives you, and then times by 3 gives you, does it? Ooh. Taylor. Plus 12. So you're a good approach, just looking at the first 2 terms, and you're like, okay, I can multiply to get to the second one. But then we test to see if we can get to the third one. You're saying plus 12. Does that work for these 2 terms? Good. If we 18 plus 12, does it give us 30? If I go 30 plus 42, 30 plus 12, does it also give me 42? Sweet. So that's a common difference. I'm just going to write CD for now. A common difference of 12. Are we okay with that? Sweet. Let's say I have 100, 50, 25, 12.5, and then I'm not going to continue from there. What am I doing there? Kenta, how do I get from 100 to 50? What options do I have? Yep, divided by 2. Or, instead of divided by 2, we say, no. Exactly right. So I'm going to write times by a half instead. So instead of divide by 2, times by a half. Awesome. Does that work for this one as well? Okay, does that work for this one as well? Perfect. So our common ratio is multiplied by a half. Does that make sense? Do I have any questions about that? Alright, last one before I let you guys get started. This is a very, very unique pattern. Let's see if you guys have seen or heard of it before. 1, 2, 3, 5. That is correct. I'm going to keep going there so that other people can see. 13, and then we get 21, and then 34. Put your hand up if you've seen this pattern before, or have heard of the Fibonacci sequence. Oh, fascinating. Put your hand up if you've never heard of the Fibonacci sequence and you don't know what this is. Awesome. Thank you very much. Now, can anyone try and figure out? I know those of you that have heard of it before, I don't want you to put your hand up. I want to give those people a chance. Can you put your hand up if you reckon you can try and figure out what the pattern here is? Yes.
Is it like the one, like with the, let's say, just go from 1 to, is it 1 plus 2, 3, then 3 plus 2 is 4?
That's correct. Whatever term we're looking at, let's say we look at this term right here. That term is the addition of the last two terms. It's a very unique sequence. So I say 2 plus 3, which gives me 5. Let's say I pick this term over here. It's 8 plus 13, which gives me 21. Yes?
Isn't it like x equals term plus 2 or whatever?
Yep, that's terminology that we won't use in year 7, but that's correct.
We did it last year.
Awesome. Do I have any questions about what we're doing today? Great. Can I get you guys started on exercise 3H? If you have the new textbook, the blue textbook, the questions start on page 149.